All right, so today in this video, we are going to see what are complex conjugates and how to divide two complex numbers. So complex conjugates or conjugate of a complex number, we're going to do this today. So let's say that we have a complex number z is equal to 2 plus 3i, and its conjugate is denoted by z with bar on top of it. So z bar is z bar denotes conjugate of a complex number, and it is given by, you just have to change the sign of the imaginary part. Okay, so 2 plus 3i, when you change the sign of positive 3i, it becomes negative 3i. So it is 2 minus 3i. So these two are called conjugate pairs. Okay, so just remember that you only have to change the sign of the imaginary part and not the real part. Let's take one more example. Let's say that we have z is equal to negative 11 minus 99i. And you want to find out what will be the value of z bar. So as I said, you will not change the real part. So negative 11 will stay negative 11. And negative 99i becomes positive 99i. So these two are called conjugate pairs. Okay, so both of these are conjugates of each other, and both of these two are conjugates of each other. Okay, so in case of real numbers, you must have done opposite numbers or additive inverse. So for example, additive inverse of 3 is negative 3. Additive inverse of negative 8 is positive 8. Right? So just like this, in case of complex numbers, we just change the sign of the imaginary part. Now, this concept is actually used in division of two complex numbers. So in Algebra 2, you have done addition, subtraction, and multiplication of two complex numbers. For division, we will use the concept of conjugate of complex numbers. Now see, whenever you are doing any operation on complex numbers, whether it is addition, whether it is subtraction, whether it is multiplication or division, your final answer has to be in the form of a plus bi. Okay. Right now we have, if you see this is actually one complex number is divided by another complex number, and you have to find out the quotient of this term. So right now you have this form, right? A plus bi divided by c plus di. There are two different complex numbers, and we have to reach to a form where only a plus bi remains. Okay, so we actually have to get rid of this term from the denominator. We have to get rid of the imaginary term from the denominator. So what we'll do over here is, first step. So this is actually a lengthy process, so pay attention carefully. First step is, we are going to find out conjugate of denominator. So first we will find out the conjugate of denominator. Okay, so your denominator is 5 plus 4i, so its conjugate will be 5 minus 4i, right? Second step, we will multiply the numerator and denominator. Okay, multiply the numerator and denominator by this conjugate. So by 5 minus 4i. Okay, so let's do that. So we have 2 minus 4i over 5 plus 4i. We will multiply the numerator and denominator by the conjugate of denominator. So that means 5 minus 4i why are we doing this? You should always ask this question. Why we are multiplying the denominator? Why we are multiplying both numerator and denominator by the conjugate of denominator? So the reason is, if you see the denominator carefully, if you see the pattern, this is actually in the form of a plus b times a minus b, right? In place of a, we have 5. And in place of b, we have 4i. And if you recall the identity of a plus b times a minus b, so this is nothing but a square minus b square. Right? So 5 plus 4i times 5 minus 4i will become 5 square minus 4i square. Okay, so I'm simplifying the denominator separately over here. See, I have applied this identity, right? So this becomes 5 square is 25 minus 4i square. So 4 square is 16 and iota square is -1. So I get 25. This will become -16 times -1, that is positive 16, which is nothing but 41. So did you see what happened here? In denominator, because I was able to do the square of the iota term, so iota disappeared, because we know that iota square is -1. When we take square of iota, it just disappears. That is why we multiply first by the conjugate, so that we are able to apply this identity, so that iota gets squared and it disappears. So in the denominator, we are just left with 41. So now we'll simplify the numerator. Okay, so I'll just distribute 2 minus 4i. Okay, so 2 times 5 minus 4i minus 4i times 5 minus 4i. And in the denominator, we just have 41. Now 2 times 5 is 10. 2 times -4i is -8i. -4i times 5 is -20i. And -4i times -4i. Let's do this over here. See, we just did 4i whole square. Right? 4i whole square. We got -16. Let's just do this again. Okay, 4i times -4i times -4i. See, -4i times -4i. So -4 times -4, and let's do iota and iota separately. So -4 times -4 is positive 16, and iota times iota is -1. So this is -16. So -16. And in the denominator, we have 41. So now let's collect the like terms together. So 10 minus 16, you get -6, and -8i minus 20i, you get -28i over 41. And we distribute 41. So we get -6 over 41 minus 28 over 41i. And this is in the form of a plus bi, right? This is in the form of a plus bi, where value of a is -6 over 41. Value of b is -28 over 41. So this is your quotient. When you divide those two complex numbers, this is the final question that you will get. Now, once again, let's just see what we did. We found out the conjugate of the denominator. So conjugate of 5 plus 4i is 5 minus 4i. Step 2, we multiply the numerator and denominator by this conjugate. Why we are multiplying both numerator and denominator? Because you can change something, right? Like you cannot just simply multiply just the denominator by something. So we always multiply both numerator and denominator by something. Okay, so I am multiplying both numerator and denominator by 5 minus 4i. So I'm not changing the value of this term, basically. And by doing this, what happens is in the denominator, we get the square of the iota term because of this identity. And then it will always happen that iota will disappear, and we just have to simplify the terms in the numerator. And that's it. So this is how we divide two complex numbers.